Welcome everyone. This is a webinar for the Embark flight planning tool. My name is Michael Rondinelli, and I'll be one of the product developers involved on Embark. With me is Sebastian Scher. He's going to be giving a demonstration and a certified pilot and was instrumental in helping us develop this tool. So, what is Embark? Embark is a tool to create flight plans customized for every pilot. It's an automated, not automatic, pre-flight planning tool. It's meant for general aviation pilots. I say automated because instead of doing everything for you, we actually give you a peek behind the scenes so you can understand why we make certain planning decisions and you can influence those in an interactive way. Using this method, you can create tailored flight plans in seconds and do that using a variety of public and proprietary data sources. So you gather all of the relevant information from the FAA, the National Weather Service, NOAA, and others. Combine that with some proprietary map technology that we built at Near Earth and use that to produce flight plans for you. First, some basics. Embark, in this present incantation, is a tool for VFR flight planning for fixed-wing aircraft in the continental United States. It's also intended for single-hop trips, so not multiple fueling stops along the way. The architecture behind it allows it to be much more than just this, but and as you might be aware, it's always easiest to limit your scope to start with to make sure that you're producing a good tool, and that's the area that we focused on. Embark allows you to design customized aircraft profiles, so all of the dynamics about the aircraft, your desired cruise speed, altitude, climb and descent rates, those sort of things. Could be tailored to an individual aircraft. You can build that from a template designed for common aircraft and then tailor it based on your own experience. It allows you to compare alternative flight plans for the same trip. So you can see the difference in hazards that they encounter along with the difference in time, fuel consumption, etc. It gives you easy tools to estimate your time of arrival, your fuel consumption, and allows you to plan based on shortest distance, duration, or fuel. This is a screenshot showing some of the features. We're actually going to have a demo for you shortly. What it allows you to do in this screenshot, you can see the different airspaces that a flight path is taking you through. You can actually click on any of the objects you see on the map to get lots of details that the planner used to help craft the plan. And it demonstrates this, what we call risk bar, this row of icons that is your main interface to the planner to allow you to interactively choose and edit your paths. So you'll get a really good demonstration of that as well. So some of the things you can do with that tool, you can identify hazards and certain obligations, requirements on the map. For instance, flying through larger airspaces like Class B that you'd encounter at large airports. It allows you to identify certain risk factors and avoid them, things like icing, mountain obscuration, turbulence. You can fly around convective weather patterns, you can avoid high terrain, you can avoid flying over large bodies of water. The system will automatically exploit tailwinds to minimize your fuel costs. It will maximize the availability of good emergency landing sites. This isn't something that we often want to think about, but it's one of the tools that are built into the suite. And you can select your tolerance level for turbulence in flight and choose your route accordingly. So without further ado, I'd like to hand it off to Sebastian Scher, and he's going to give you an interactive demo of Embark.
Thanks everybody for taking the time and to look at our demo. Before we go into details, just want to kind of give you a little bit of the rationale of why we wanted to do this. And as you know, you should be familiar with all available information before a flight. And our tool doesn't replace what you already do, but the idea is to say, okay, there's a lot of complex decision making that you have to make when you're doing a cross-country flight. And so there are many factors, and doing the trade-offs in your head and manually is not something that people are very good at. And so the way that's done today is you have your EFB, like ForeFlight or Garmin Pilot, that allows you to show different data layers, and you're kind of making some guesses and trade-offs on, okay, do I go, do I fly through less weather with more mountains, or so it's a very difficult kind of trade-off. And so the idea is to help with this. And additionally, this kind of planning takes you a long time, and so by the time you're ready to fly, what you were just spending a lot of time on thinking about might already be outdated. So the idea was to give you something where you can quickly optimize this plan and then transfer them over to your EFB or avionics to then give you some guidance. So next I'll give you some demos that show some of the features, and then it would be great to get some of your feedback also on what are the things that you like, what are missing, just to get your feedback and sense of what this could be. I just want to kind of point out a couple of limitations ahead of time. So we don't have special use airspace and TFRs in there right now, and our terrain altitude is a little optimistic. We don't consider obstacle databases, and the airports we consider is not every airport that exists for the kind of the larger 4-letter ICAO airports. So let's get started with some example. Imagine you wanted to go from Allegheny County Airport in Pittsburgh to escape to the ocean, go on a nice vacation, so that's kind of becomes a pretty interesting flight right away, because you're going through the Bravo here. There's also the Cifra. Today there's some icing forecast along the route here, and you have mountain obscuration and turbulence. So it seems like it would be a fun day to fly. So let's say you don't really want to deal with the Bravo or sneaking through there. Then it will give you a route that's to the north and go down. It also avoids some of the water. And then, but now, let's say you also don't really want to deal with the icing. So then you can click that, and now it kind of routes you the other way around. So it will go to the south. Now here it will show you also that you're gonna fly 5 miles over water, and then basically cross down here. Now once you have that plan, you can take a look at it down here. So these are all basically it constructs the path out of 5-letter waypoints, VORs, and airports. And so to get it over to your favorite tool, for example, you can just copy the flight plan, and then let's see, for example, here I just have my iPad open. I can just easily paste that route in here, and now I have the route in ForeFlight. Or you could imagine if you on your avionics, right, you could type in those waypoints into your avionics, and then it would be easy to basically fly this path on your avionics. And in addition, the altitude its outputs respect VFR altitude, so below 3,000 feet. You don't have to be on an AGL, you don't have to be on even on odd altitude, so just take that into consideration and then also, all pilots fly east, so it, will put you at 5,500 feet. So let's maybe just show a couple of other examples that show some of the features. So say you wanted to go from Myrtle Beach to Key West. Hope you have a nice flight right now. So you can see that the shortest path goes over a lot of water, and I will highlight this here. You're going over 30, the closest shoreline is 30 miles to you, and then the path the planner comes up by default avoids the shore and then kind of sticks along the coast. If you don't want to fly, have any kind of interaction with Bravo airspace, it will kind of guide you closer to the shore here and avoid, for example, the Orlando class Bravo airspace. There is another example here. Let's see. So let's say we wanted to go from Allegheny County to Key West. That's not something that should be feasible. So, but it will try to plan. And you can see for that route, it takes a little bit longer to plan. But you can see that somewhere around Orlando, you would probably run out of fuel, and also show you this as a hazard. So it's it would require refueling. It shows you that you have Bravo airspace. You're going to be flying through some turbulence and over a lot of water. I think that would be probably here if you would go directly to Key West. So another example is if you look at on the side here, you can turn on the different airnets, signets, and so on. So you can see that in the Midwest, some convective signets. So some route here where we're going from Seminole to. So there's you can see here there's a signet in between, and so when we're planning it. It might be that the signet's not active anymore. So let's choose something a little earlier. Well, this is the live demo. Oh, so it avoided the signet. Okay, yeah, so you can see that it actually, right, so since it's not active, you don't actually, right, so the shortest path you can see it shows the signet. Right, so the icon tells you, hey, you'd be flying through a signet, and then the shortest path, this path will kind of sneak through the signets here. If you really want to fly this, that's your decision. But the idea is that it can avoid that it will not let you fly through signets if you don't want to. Here's another example that kind of shows the height. So imagine you would want to fly in this area. This is in Wyoming. There's a big mountainous area in between. Which starts getting to the service ceiling of a lot of kind of aircraft that we fly. And if you take the direct route, you can see that it highlights, hey, you're really gonna go to a high altitude, like 9,700 feet, and then this would be one way to go around it. And so this is one example. Now, the features that are in here are you can calculate the route by different objectives, so distance, duration, and fuel consumptions. Additionally, you have different hazards that you can avoid. So these are the higher elevation, bodies of water, And then these are risks. So risk to bystanders and risk to people, to passengers on board. So the idea for this is, for example, let's say, here's one example to avoid the risk to bystanders. Imagine you're flying in Chicago, and one way to avoid Chicago, and most likely you would not fly this route in general, but is to avoid the Bravo airspace. But you could also think about, like, what is the risk if I had to do an emergency landing, and what would be the impact to people on the ground, or what would be the impact to pilot and passengers on board. So if you turn this on, it will avoid trying to fly over people, essentially. And then something else, this is, since this tool is updating in real time, our demo is going to have to keep on adapting. So this is just something we worked out right now. Is so, for example, there's currently quite a bit of wind in this area, and depending on what you choose as the objective, the system will update, optimize the flight. So here the flight time is actually, even though the route is longer, the flight time was lower 10 minutes ago. I guess not anymore right now. so then this is also the other feature here. As you can see that if you want to get out of the icing as quickly as possible and fly that way, if you click this button, it will recalculate the route to avoid this airmat for icing. Some of the other features that Michael mentioned is, so you can set up different aircraft with different performance metrics, and it also kind of keeps a list of all the plans you've ever planned. And so those are kind of some of the examples we wanted to show. And